Greetings. So the question is like this: which of the following option correctly describes the variation of the speed? Okay, he is asking about the variation of the speed. Okay, and acceleration. Okay, acceleration of a point mass falling vertically. It is falling vertically means it is a free fall case. Okay, falling vertically in a viscous medium that applies a force F is equal to kV. It is applying a force F is equal to kV. Since the force viscous medium force F is equal to kV means it is a resistance force which is actually opposing the motion, where k is a constant. And one more line he has given: the graphs are schematic and not drawn to the scale. They are not actual scale graphs, they are schematic graphs. So we can observe the graphs. Here A is decreasing, V is increasing constantly. Here V, after increasing to a certain time, it is coming to the rest, and A is constantly falling down. And here if I see the C1, V velocity is constantly falling and A is increasing up to some point and it is becoming constant. If we consider this case, when a body is falling down in a vertical medium, vertically, it's a free fall. And if we check the forces, this is mg downward force, and there will be upward force, what we say the viscous force, that is given by what? kV in this question. So when he has given these things, okay, mg and kV are the two forces acting on the body. And when we discuss about any body which is having viscosity, Stokes theorem comes into the picture. So whenever there is a Stokes theorem in this picture, okay, we can say that a body falling freely in a viscous medium, slowly it comes to a part where it attains equilibrium, what we call it as terminal velocity. It reaches to a point where we say that it is a terminal velocity, where the acceleration will be become zero. It means as initially the velocity is equal to 0, as it is coming down, its velocity keeps on increases because of mg force, but at some point its acceleration becomes 0 and it reaches to some potential terminal potential. So terminal velocity, it reaches to a point what we say it is terminal velocity. It means from 0 it is keeps on increasing and at some point it is becoming constant. So just by looking into the graphs, we can say that it keeps on increases and it is coming to the constant, that we have only in these two cases, either B or D. It cannot be A, because A is gradually, it keeps on increasing from some point here. Okay, it keeps on increasing some point at this point here. Okay, and it is keep on increasing. But if you see B and D graphs, it is rising from 0. And after some time it is attaining to a common point, constant value, velocity, what we call it as terminal velocity. It comes to that point, it reaches to that point. And here also it cannot be a graph, because C is also not a good option. Reason here the velocity is decreasing gradually from maximum, but that is not the case in a free fall. So A and C are a wrong graphs, so we can leave the A and C. Now the tug of war between B and D. So in order to solve this, we will go for a free body diagram. Okay, so free body diagram gives us the net acceleration ma is equal to, since it is downward force is mg minus the force Fv, viscous force, that is kV. Okay, therefore A is equal to g minus kV. So now we have to check for what is V. Just by analysis we can say that, okay, the A gradually comes to the rest. That maximum velocity what it attains, Vt, that is terminal velocity. That terminal velocity will be attained when acceleration A is equal to 0. Therefore that will become G is equal to K. So here we have, this is divided by M, I missed it, Kv divided by M. Therefore V is equal to mg divided by k. This is the terminal velocity. Okay, this is the terminal velocity or maximum velocity with which it rises to. Now if I say A is equal to G minus kV divided by M, I can write it as dV by dt is equal to G minus kV divided by M. Now dV divided by G minus kV divided by M is equal to dt. Integrating on both sides, this is from 0 to t and this is from 0 to v, and this is in the form of integral of 1 divided by ax plus b into dx. This can be written as 1 by a ln of ax plus b. So using the same form, we can get here 1 minus 1 by k by m, that is minus m by k into ln of g minus kv divided by m from 0 to v. If anyone requires this integration how to do, you can just send me a comment so that I can send you the solution for this also. Therefore this is equal to minus m divided by k, applying ln of g minus kv divided by m is equal to t minus ln g is equal to t. Therefore this can be written as minus mk into ln of g minus kv divided by m divided by g, applying the logarithmic rules, is equal to t. Therefore ln of g minus kv divided by g is equal to kt divided by m minus kt divided by m. Therefore rising on both sides with exponentially, we'll have g minus kv divided by m g divided by g is equal to e to the power of minus kt divided by m. Therefore this will become 1 minus kv divided by mg is equal to e to the power of minus kt divided by m. This implies that 1 minus e to the power of minus kt by m is equal to kv divided by mg. Therefore v is equal to mg divided by k into 1 minus e to the power of minus kt by m. But we know that previously mg divided by k is vt. Therefore this will become v is equal to vt into 1 minus e to the power of minus kt divided by m. So considering this expression here, okay, we have acceleration in the upper one, we have g is equal to acceleration a is equal to g minus kv divided by m. But here we know that v is equal to terminal velocity into 1 minus e to the power of minus tk divided by m, which is exponential dependent. If I substitute here this also gradually decreases as the v value keeps on increases. As the v value keeps on increases, a value gradually decreases. Okay. Therefore here if we observe B and D option has a straight fall, which is not an appropriate one. So B option is the right option. I hope you understood this one. Thank you.